Hello, everyone. Welcome to the Neo4j online meetup. Today, we will have Will Lyon and Mark Needham from the Neo4j Developer Relations team present to us on their graph algorithms project on the Yelp Dataset. We suggest that you set your resolution of the video to 720 megapixel. You can adjust it on the bottom right of the video. And if you have any questions while watching this, you can ask it live in the chat window. But if you have any questions after the video is over, the live stream is over, you can ask the presenters directly on the Neo4j community site, which you can find the discussion thread link in this description. And if you enjoyed the presentation, give it a thumbs up. Also, if you're interested in presenting in the future for one of our online meetups, you can post about it in the community site under projects or content, and that's how we're going to be selecting our projects. I think we can get started. And Will, Mark, do you guys want to introduce yourselves and get going?
Sure. So my name is Will. I work on the developer relations team at Neo4j.
And I'm Mark, and I'm Will and I are on the same team. And so what we want to do today is explore a data set that I think Will may have been the first one to play around with this one. So this is the Yelp Dataset challenge. So I guess maybe we can hand over the control to Will, and he can quickly give us an overview of what it looks like.
Yeah, let me just share my screen here.
So while Will's setting up, so our plan, this is to roughly sort of show you how do you go from this raw data set into Neo4j, and then once we've got it into Neo4j, what sort of interesting insights can we get into that data set using the Neo4j Graph Algorithms Library. Cool, I can see that Will is now ready.
Great. Yeah, so this is the landing page for the Yelp Open Dataset. And if you're not familiar with this dataset, Yelp has been releasing versions of this dataset for several years now. I think I first came across this several years ago, and they released it as sort of part of a data challenge where they challenge students or people interested in just analyzing, working with the data to try to do interesting things with the data. Can you say, for example, find recommended businesses for users? Can you do some interesting machine learning applied to the photos, this kind of thing? And what I like about this data set is that it's actual real world data. So this is data that Yelp uses and collects on their site. So it's great for looking at how we might model that data in Neo4j, how we can build applications that work with this data. So we've played around for it a bit, and recently we've been working on a applied graph algorithms online training, and we decided to use this data set for the training. So what I thought we could do today is take a look at the Yelp data set, how we would model it as a graph, how we would import it, and then give sort of a preview of the application that we're building for the applied graph algorithms training. So the first thing we want to do is figure out how we're going to model this data set as a graph in Neo4j. And I like to use this tool called Arrows. So in my other window here, I'm going to open up Arrows, and we can share the link here to that tool. But if you're not familiar with Arrows, Arrows basically allows us to draw out our graph data model, or actually we can represent actual data in Arrows and then translate that into Cypher, so we can load that into the graph very easily, or we can use it to model just sort of the meta model. So what I like to do is take a look at the data that we have, and then at the same time sketch out the data model that we want to create. So if we look at what the Yelp data set has here, we have businesses, we have reviews, we have users, we have check-ins. These are sort of aggregated check-ins. We have tips, so a user can write sort of some secret information about a business. And then we also have photos. So Each photo has an ID that's connected to a specific business, and there's some caption and label for those. So the first step in graph data modeling is really to identify what are the entities, and those entities, the objects, the things, those become nodes. So I know, well, we have business, so we're going to give this node the label business, and then the next step is to figure out the properties, and the first property we should think about is what is the property that identifies uniqueness. And here we have a business ID, so that's a pretty good indicator. That's going to indicate uniqueness for us. And then we have other things like the address that are unique as well. We have latitude and longitude. Now in Neo4j, we can represent these as a point type. So we could say maybe location, which is going to be a point, and this is really a combination of latitude and longitude. This would allow us to create a spatial index in the database, something like that. Okay, so that's good enough for now. Let's start with that. And then we next have reviews, and we have users. So, well, we know user, that's going to be certainly a node for sure. So we'll create a node with the label user. We have user ID, that's a string, that's going to identify uniqueness. User also has a name, that's a string as well. So this is fairly straightforward at this point, but now we want to model our reviews. So we see that a review has an ID, and it's connected to a user ID and a business ID. So these are sort of like foreign keys, if you want to think of it that way. And now here's really the first question that we have. Should we model a review as a node or a relationship? So we could certainly model something like this, where we say user reviews a business, and we could store the stars, sort of the rating, as a property on the relationship. And we could do this, but there's maybe some use cases where we would actually want to model reviews as a node. Let's say if we wanted to apply some NLP techniques, maybe where we're going to extract some metadata, like do entity recognition or something like that, where we actually want to have nodes that point to our review. And in that case, then we would want to have something like where user writes a review, and now the review is going to have stars, and it has text, and it has a date. So here's another choice where we need to choose the right type. So we have several temporal types available to us. We have things like date time, which takes into account date and time zone. We also have local date time, which is date and time, but without time zone. In this case, as you can see here, we just have year, month, day. So the correct temporal type we want is just date. Okay, so user writes a review, and now we need to connect the review to the business. So we'll say this review is a business. And some other data we might want to take into account here. If we look at some of the attributes here of our business, we can see that we have categories. Now this gets to another common question that we have in graph data modeling, which is should categories in this case be a property on a node, right? So we could say categories is going to be a list of strings, and we could just have these duplicated as node properties. But that's not necessarily the best way to model it. So when it comes time to think of, should this be a property or should this be a node? Should we have a category node? The way I like to think of that, the answer to that question is, well, if I query through this thing, if I query from business to category, then to other businesses, is there something useful that I can uncover? And one thing we might want to do is find businesses that are in similar categories or have overlap of categories, because that's going to possibly be a relevant recommendation for someone. If you like pizza places, let's find other pizza places, for example. So in that case, we will not model category as a property. Instead, we'll create category as a node label, and we'll have category nodes connected to businesses. We will call this in category. Okay, so user writes a review. The review reviews a business. That business is in a category. We also have photos here. And if we take a look at photo, we see that photo is connected to business. And then we have caption and label. So let's go ahead and add photo that's connected to the business. We don't have the user that took the photo.
Sad they don't have that. It would be a really fun addition.
Yeah, exactly.
Although maybe, I don't know whether those are like assigned photos or the ones that, I don't know. Can you actually upload photos on Yelp? You can, right?
Yes.
Yeah.
So I'm assuming these are all user uploaded. I mean, Yelp is
taken out the user identifying information then.
Okay, so this now is a pretty complete data model for this data. One thing that I sort of wanted to get across here is that we have some process that we go through, right? We identify the entities, those become nodes. Then we identify the properties. We think about how they're connected. Those become relationships. And one thing that's important is our model is very much informed by some of the use cases that we have with the questions that we want to answer of the data. So when we come to those questions of should this be a property or a node, or should this be a relationship or a node, then I like to think through, okay, well, what are the actual use cases? How am I actually going to query that? And as I think through that, that sort of helps to inform the best data model for our case. So now that we have our data model, the next step is going to be to import this from these JSON files that we're able to download from Yelp and into Neo4j. And Mark, do you want to walk us through that bit?
Yeah, let's switch to me. So, can you see that fine?
Yes.
Okay, great. So when we're trying to figure out, once we've kind of figured out roughly what we would like our model to be, we need to pick the most appropriate tool for importing it. Now, typically, if you're just doing a prototyping type thing with a reasonably small amount of data, you can probably just use the load CSV tool, like get your data into CSV format and use that. If you don't want to do that translation, you can use the APOC library and load JSON using that tool, using that procedure. For this one, there's quite a lot of quite a lot of data, and Will and I are quite impatient. And so we have decided we're going to use the Neo4j import tool, which is a tool for importing data, and it basically creates you a Neo4j database. So it kind of, you get a completely new Neo4j database that you can then point your Neo4j server at. So one thing it doesn't point out on the data set on this page is that they also give you a friends network. So there's a Yelp friends network, and that has a lot of relationships. So that's the bit that takes the most work. For those of you who haven't seen the Neo4j import tool before, if you search for Neo4j import, you'll get to this page of the operations manual. And it kind of, this sentence pretty much explains what we want to do. So we're doing a batch import of a large amount of data. And at the moment, this is appropriate only for an initial sort of bulk import of a data set. So our first thing is we've got to get the data into the format that this tool expects. So let me just quickly show you on the documentation what that looks like. So it expects to get CSV files, and they should have, I'm trying to see, there should be a header example somewhere on this page. So they expect to have almost like a DSL in a CSV format. So they expect on the top of your CSV file, you need to specify what attributes you want to create on your node. And one of those needs to have, for the nodes, it needs to be a colon ID needs to be in one of the columns. And that's the unique identifier. And so we could use the unique identifier that Will pulled out on the model on the previous page. You can then specify some other properties as well. And if you want to specify a type, you can specify that. If you don't specify a type, it'll be created as a string. And there's also another special syntax called colon label, where you can specify the label that you want to be applied to the node on a particular row. In our case, all of our nodes in a particular file are going to have the same label. So there's another syntax that we can use for doing that. Okay, so we're going to create these. So that's those are the files that we create for the nodes. We then need to do the same thing for the relationships. And you can see on here the special header values that you need to have. So you need to have one called start ID, one called end ID, and one called type. Although the type, again, if it's the same type all the time, you can specify that from the tool. And this is how it would look like. So this is in the sample example. So we've got a start ID, Keanu. There's also an option, a property in here, indicate this would be a property on the relationship. And then we've got an end ID, which is there. And then this file, you can see here, it's got acted in 10 times or in a row. Okay, so how do we do that for the Yelp example? So we've got a repository here. So if you, we can probably paste this one into the chat so you can have a look at it later on if you want. But this is on Needham Yelp-graph algorithms, and we've got some instructions if you want to play along. It sort of gives you instructions of how you would go about using this script, or this set of scripts. So you can see the first thing is download the files, put them in a dataset folder. Once we've done that, we have created a script called JSON to CSV, and that will get you from the JSON files that Yelp provide to the CSV files that Neo4j, the Neo4j import tool needs. So let's just have a quick look. What does that script look like? So this is the script. I'll zoom it in a little bit. Hopefully that's big enough. So let's go from the top. So this is just a massively procedural file. So I don't think I'm getting any marks for good Python here. Our colleague Nigel Small would probably be very unimpressed with this Python, but there we go. And you can see what we're doing is this script can kind of be run multiple times. So on the first line, we're just checking, have we already created a business header file? So maybe that's actually another thing that I forgot to point out is you can separate your header from your header file from the rest of the CSV file. And that works quite well if you have really big CSV files. And if you make a typo creating the header, it would be really painful to have to open up that massive file, change just the first line, and then carry on. Whereas if you've got it in a separate file and you make a mistake, you can easily either generate it again or just go and edit it. So we're not really doing anything fancy here. So on lines 12 and 13, we are respectively opening the Yelp JSON file. I think they've changed the name of this file. So we have another branch that works with the most recent round of data. This was round 11, but there's another branch for round 12. And then we've got our business CSV file. So we're just getting that into a write mode so that we can write to it. And then all we're doing is we iterate through the JSON file. It's a little bit weird. It's not quite the JSON that you would expect to get. So you can't actually just feed it straight into the Python JSON library. It's because effectively you've got one line and then JSON individually on each line. So you've got like a streaming JSON format. So we actually process it, sort of read the CSV file, and then we process each line as a piece of JSON. And then all we're doing is saying, okay, from that JSON, let's take out the business ID. So the business ID goes in column 1, the business name in column 2, the address in column 3, and so on. So that's the business file. We've got a bunch of other ones here, but let me just show you the one which is probably most interesting for this session. We're also building one for categories. So similar sort of thing here. We build a category header. We're reading the categories, and and we're reading the categories file. What we're also doing in here is actually creating a relationships file. So you can see in the name of the file, we say what exactly does that file contain. So it's business in category. And you can see here we specify a start ID and an end ID. In brackets, we're also specifying the equivalent of a label for the tool. And so this is so that if you happen to have some IDs that clashed, it'll know, okay, the ID that I'm seeing in this column is specific to the business label or the business group. I forget exactly what it's called for this tool. And then on our next line, we're building up, we're iterating through the businesses, JSON file again to get the businesses. And we write the business along with its category. So there'll be a lot of repetition in here of the business ID. You'll see the same business ID on multiple rows. And then actually this naming is terrible, but this is unique categories, clearly copy and pasted from another one. And then we write the categories into that file. And once we've done that, we'll end up with a bunch of CSV files that we can process with our Neo4j import tool. That's on this next tab here. So this is what a Neo4j import script looks like. So the way you call it, so we're assuming that this script is run from the root of the Neo4j server. So bin Neo4j admin import. I tell it you should expect a CSV file. We'll also tell it where do you want to write it. So this will get written. If you run this, it'll put it under data, databases, and then whatever that name is. So in this case, data database is Yelp DB. And then you need to specify -- nodes. And in this case, we're actually saying everything that follows needs to get the label business. And then we can specify our files, comma separated. So header and then the file, and then we do the same for categories, same for users, and so on. I'll just skip down to here so you can see we do the same for relationships. Notice again, we didn't specify the relationship type in the file. We just pass it in on the command line because we know that it's the same for every row. Once we've done that, we can run this, and I think it takes 3 or 4 minutes to create this one, so it's not too long. But I'm going to cheat a bit and skip ahead to the point where we've got the data loaded.
So Mark, if I can jump in and ask a question here. So you said earlier that we could also just use the APOC load JSON that works with streaming JSON as well. Yeah. But because we had sort of a large data set, we wanted to use the import tool. Is there some sort of guideline for the size of the data when we should use the import tool and when we should use APOC load JSON?
Yeah, I guess a little. I mean, it kind of. I guess a rough rule of thumb is sort of 1 million to 10 million things is probably a reasonable amount to be doing it directly in Cypher. If you're doing, so when I say directly in Cypher, so anything that has the database running and then you're processing some data imports, if you're using load CSV or if you're using the load JSON procedure, all of those are processing data in Cypher. And they're also writing data to a transaction log, which is then applying it to the database. And so you've kind of got a two-step process, and so that's the reason it does that is for the safety of the data, but the disadvantage is it's slower to do it. It also kind of depends on your patience level as well. I think if you're happy to leave it running for a few hours, and you then probably we could probably just about maybe get away with using the load JSON tool for this.
Gotcha. So in this case, because our data is tens of millions of nodes, it makes sense to use the import tool. Yeah, and then I suppose if we had a bigger data set where we're up to billions, then probably we really would be waiting for a long time for it to all be processed directly in Cypher. So the data set we're gonna play with in this session is the one on this. So this is actually, maybe I'll explain. So this is the Neo4j desktop if you haven't seen it before. And you see you can create projects, and I've got my Yelp project just here. And you can see that you can specify lots of different graphs inside a project. The one that we're going to be using today and the one that we use in the training session is the Phoenix data set. But you can see over here, this is how much data you get if you load the whole thing. So we've got 7.9 million nodes and 28.7 million relationships. For the Phoenix one, we've got a bit less. I'm going to switch over to the Neo4j browser. So that's sitting over here. And you can get
a quick overview of what we've got in the database. So you can see we've got just over 1 million nodes and 2.5 million relationships. And as with any data set, you can kind of click on these things and it'll run a query, and you can sort of navigate around like that. I thought I'd just show you what what we ended up with for the schema based on the schema that Will laid out for us in the modeling section. So we've added in a few more things, but mostly it's the same. So remember, we had our user wrote a review, and the review reviewed a business, and then the business had a photo. Business is in a category. We've added a couple of extra things. So we've got the business is in a city, and the user can also write a tip. And then I mentioned the friends graph as well. We've got that down on this bottom side. So what we want to do as our first use of graph algorithms is on the businesses. So I've kind of got a query already made for me somewhere up here. There are all the businesses have categories. So this is a query showing a business or 3 businesses actually, and the categories that they have. So you can see here we've got original hamburger works, has was it 6 categories? It's got burgers, dive bars, nightlife, restaurants, sandwiches, and so on. And then the coffee bean and tea leaf has just a couple. And the categories in Yelp are kind of they're basically just tags. There's no structure between them. There's nothing to say like, oh, one of these is a subset of this other category. There's no category hierarchy. And so it would be quite interesting if we could actually find that structure. And so we've actually got an algorithm in the Neo4j Graph Algorithms Library called overlap similarity. So this is one we put in the library about 2 months ago, I think. And the idea is that if you give it 2 collections, it'll tell you the similarity between them and effectively tell you how much of a subset one is of the other. So we can kind of work out whether we've got subsets of categories. And the way I tend to build these queries is I take the example that's in here and then I adapt it to do whatever I'd like to do. And so in this case, what we want to do is find similarity between categories and sort of see if we can find some subsets. So I'll just space it out a bit so we can see what we're doing. So we're going to use, to begin with, we're going to call the streaming version. And what the streaming version does is it gives you back the results to your query. There's also a write version, which will store the data in the database. And so what you need to give it, an array of maps. So that's this line here. And the item value needs to be the thing that you want to do the subset on. So in this case, it's going to be category. And then, the naming is a bit weird for this particular example. And then the categories is, okay, what do I consider to make up the collection that I want to look for the subset on? And in this case, it's going to be the business. So I want to compare which businesses are being tagged by which category. And then all we need to do for our last step is just go and fill in this bit here. So we'll change this to business, and we'll change this to business as well. And we'll just say the business is going to be in a category. So we're just using Cypher to help us get the data into the structure that we want. And then all I'm going to do, I'm just going to get it to return, let's say, 25 results. So we're building up our array of maps here. We call the algorithm here. Every time you call a procedure, if there's Cypher preceding it, you need to yield back some values from it. So that's what we're doing on this line. And then we've got a function that will actually look up the node, and then we'll get the name of it. So if we run that, this is what we get. So you can see a lot, like if we just read from the right-hand side, it's telling us that the value on the left, so in this case waxing, the category waxing is 100% similar as the beauty and spas. And what that means, so the way that effectively, like if you look at the data, what that means is that every time a business tags itself as waxing, it's also tagging it as beauty and spas. And the same thing for hair salons. Every time a business is in the category hair salons, it's also beauty and spas, and so on. And so there'll be loads of different ones. So maybe we can find a food one. So, I mean, this one's kind of makes sense. Specialty food is a subcategory of food. Okay, so this is cool. So we can kind of explore the data like this. Oh, by the way, I didn't explain these other numbers. These are how many businesses tag themselves as waxing. This is how many businesses tag themselves as beauty and spas. And you can see that for waxing, every single time the business is tagged as waxing, it's also tagged as beauty and spas. So the intersection value, so basically we're taking this one and we're dividing it by the smaller number. And that's our result. So the first 25 at least are 100% compatible. What we're going to do next is we're going to actually store a relationship between these values. So we'll just go back to the documentation again, and if we scroll down a bit, we'll find a right version of the algorithm. So here we go. The right version will, by default, it doesn't actually write. You need to tell it to write. It will, by default, return you back the distribution of the values that it's computing. So let's maybe just have a quick look at that. So I'm gonna paste this one just below, and all I need to do is just copy this bit from my previous query, and then delete this and paste in. So I just need to paste in that bit there. So everything is the same. We've just kind of got rid of the stream, and then there's been a little bit of a change here. So let's just set this to false, and we'll let's say a similarity cutoff of 0.5, so we can just see how this works. So if we run this, you can see what it's come up with. For our categories, it's found 3,500 similar pairs. It didn't write anything, but it defaults to a right relationship of narrower than. The mean similarity score was 0.84. Remember, we filtered on 0.5, so it doesn't. We could actually also run that with a lower similarity. So we could say, hey, just show me everything so I can see the similarity. And you can see now there are some that are really, really unsimilar, but still have a little bit of similarity. But I think what we'll do is we'll set this a bit higher. Let's stick this up to 0.9, and we'll tell it to create the relationships. And if we run that, it creates 2,000 of these relationships. And let me just zoom out a little bit so we can see them. And these are these narrower than relationships in there. And this is what it does. So you see you get a graph saying snow removal is narrower than advertising, wine tasting classics is narrower than wine bars. Is that right? Yeah, and so on. I've got one extra thing that I can never quite remember, but this, so I'm going to just copy that across. So what we're doing with this query is we're going to get, if there's a direct relationship, we're kind of removing transitive relationships. So if a node sort of at the bottom of the hierarchy has a direct link to one at the top, we don't really need that link because we have it indirectly. And let's see if we can get a bit of a hierarchy on one of these examples. Still not really. Maybe I'll force one to be returned. So we can say, hey, find me ones that are 3 degrees. There we go. So that's a bit of a better one. So I'll zoom it out a bit. So you can see we've got and this is obviously completely reliant on what the data says. So in here it's saying magazines is narrower than books, music and video is narrower than magazines, and video games in this data set is narrower than magazines. Now I'm gonna pass back to Will again so we can have a look at how we might use this hierarchy.
Okay, great. Can you see my screen okay?
Yep.
Great. So, so we mentioned that we were doing this sort of in the context of working on this applied graph algorithms online training course. And this is sort of a preview of what we have for it so far as we're building it out. And because it's an applied course, one thing I want to do is sort of demonstrate how we can use some of these algorithms in an actual application. So here, let me make this a bit bigger. Here I have a React app that's running. Let's make sure it's running localhost 3000. Yep, there we go. So I have this very simple React application that's querying Neo4j with this Yelp data loaded. And we're going to see basically how we can use some of these algorithms. So first of all, to be able to talk to Neo4j, we're just importing the JavaScript Neo4j driver, and we're creating a instance of the driver, just passing in our connection credentials, in this case through environment variables, but it's just pointing to localhost on my laptop. It could be pointing anywhere. And then in our React application, so let's take a look at user profile. So this user profile component, this is basically giving us some user IDs to choose from. And when we select a user ID, it's querying the database to basically try to get what we're thinking of as like a persona. So for this user, how many reviews have they written? What's the average stars? What are the categories that they're reviewing most frequently? And the idea for this is that we select some user, and then as we go through the application, this is the user that we're doing these queries in the context of. So this is kind of like logging in, right? So here, Princess Candy Empire likes to review restaurants and nightlife and bars, whereas Dolores prefers restaurants, food, shopping, coffee, and tea. So just to show that the algorithms that we're using, the whole idea, most of these, is to sort of provide some personalization. And if we jump back to our React app, in this case, fetch user info, this is what's running our query. And we can see the query here. We have these Cypher queries extracted out into these exercise JavaScript files. So the idea, once we launch the online training, what we'll do is we'll show some basic functionality of the application, but then we want to be able to improve that function by using graph algorithms somehow. So in this case, this is just our Cypher query that's looking up a user by ID, finding their average stars, finding categories of businesses that they've reviewed, and so on. But let's look at something a bit more realistic. So I'm going to switch over here to business search. And for business search, we can search with some search string, and then we have to select a category. And let's say I'm looking for, I don't know, maybe a pizza place. Well, I can really quickly see that there are a lot of categories. And I mean, I'm not looking for a very narrow specific category. I just want to say, okay, find restaurants, something like that. And this is where the category hierarchy exercise that we just went through that Mark showed us can actually be very useful. So instead of showing all of these categories, I just want to see what are the root level categories. So here's the query that we're running. This is just saying, find all categories and just return them. But instead, what I want to find the top level categories is I want to find categories where this pattern does not exist, where there's no narrower category than this. So just find me the top level categories. And now when I switch back, now I can see, okay, my top level categories, this is much more manageable. I can select restaurants and search for pizza, and okay, now I can see some businesses and I can see some reviews for each business. Okay, so that's useful. Let's take a look at the query that we're using to search for businesses. So this is in exercise 2. So note here, when I search for in restaurants here, when I search for pizza, lowercase p, if I search for pizza with a capital P, I get the same results. And if I spell pizza a little bit wrong with 3 Z's, I still get some results here. So what we're doing here is we're using full text search. This was a relatively new feature in Neo4j. 3.5, I think, is when this was released. So we've created a full text index, and we're using that to do some fuzzy searching here. So not only are we doing a case-insensitive comparison, but I've actually added this funny matching operator. So as long as we have at least 75% similarity, we'll still find the business. And then we just match to make sure that the business is actually in that category, and we're ordering by the ones that have photos. So this is just an example of where having that category hierarchy just makes it easier to present a more intuitive UI to the user. But of course, one thing we might want to do is show more relevant reviews first to the user. If I'm searching for pizza or sandwich, I don't want to see all of the hundreds of them. I want to see the ones that, according to some algorithm, we're most likely to be interested in. And similarly, maybe when I'm searching through these reviews, instead of just looking at all of the reviews, I want to know, well, for the people that have the most similar interests as me, let's look at those reviews first because those are more relevant. So there are lots of opportunities for applying graph algorithms to the data. These are the kind of things that we're going to show you how to do in this online training when we launch this in the next month or so. But maybe Mark, maybe you could show us how we can take advantage of graph algorithms, maybe looking at some of the photo data that we have.
Yeah, yeah. Let's do that. So let's go back to the desktop again. So like we saw at the beginning, there are a bunch of photos or photos that we have here. Just the labeling's gone a bit wrong. Hang on, let's just fix it so we can read it. So for example, here we got a photo, and on the photo, I don't know what we do, maybe an ID. So photos can have labels. So we'll run these photos through the Google Image Recognition API, and they come back per photo. So maybe actually we'll just pick one photo. So for a photo, you get back effectively, they call them labels, so a bunch of labels, not to be confused with Neo4j labels, that indicate what the photo is about. So all these, this one here, these are a bunch of photos that are related to properties. And so a nice thing that we have here is that we actually have overlap between these tags. And so like how we did with the overlap similarity, we can do a similar thing, but this time we don't want to find a subset of labels based on like of similarity between photos. We actually want to just compare like how similar are they to each other. So like give us a similarity score based on the co-occurrence of those labels. I'm going to cheat a bit here because I guess we're sort of running towards the end of the time. But this is going to be another exercise. And so what we're going to do, so I'll just show you what the query should look like. So we're going to do a really similar thing to before, where we build up this array of maps, and then we pass it into, this time we're going to use the Jacquard similarity algorithm. And similar to before, where we had the overlap, if you just look above in the similarity algorithm section, you can see the Jacquard one. And it just has a slightly different formula. So it's computing a category overlap rather than working out whether one is a subset of the other one. And again, there's an example that takes you sort of all the way through. If we come back here, just to explain the other stuff we're doing, a lot of these photos are really similar to each other, so actually went with quite a high cutoff. And what we actually did here is another interesting variant of the similarity algorithms, is that when you create either what you return or what you create on the right version, you can actually specify a top K, so you can almost build yourself like a top K similarity graph. So in this case, we're saying find me the 3 most similar photos to a photo. So this one takes about 30 seconds to run. So I've cheated a bit and run it already while Will was talking. And so I'll just pick a photo. So we'll say, let's pick this photo here. So if we say, find me this photo, and we'll look it up by ID. And then we'll say, find me the similar photo. So this one creates a similar relationship. So this is like another photo. I guess I can call this other. No, bad pick. Okay, let's go. We'll go the other way around then. So if we look up, these are some photos that are considered similar to each other, and obviously, like, this is not the greatest way of telling whether or not this is working well or not. And so the idea but you can see, like, if you click on it, we can see this photo here has a similarity of 1. So they have 100% the same labels attached to them. So you can see it's restaurant, floor, interior design and flooring. And so the idea is that in the application that we build, we'll be able to actually view the photos. So you'll be able to see the similarity in terms of the actual photos rather than the graph representation of it. And from our exploration so far, what it's identified is that one interesting thing Yelp does is for chain restaurants, they put in the same photos but with different IDs. So we noticed like loads of photos and they were like all the same pizza. And we're like, huh, that's weird. Do they really sell the completely same pizza everywhere? And then we figured out that it's actually Pizza Hut, same photo representing Pizza Hut, just with loads of different IDs. So that's what's gonna be the next or one of the photo-based exercise. And then the idea will be that you can run a community detection algorithm over that similarity graph to find clusters of photos that are the same.
Cool. So I think we're about out of time, but Mark, for folks that are interested in learning more about this, we said this is part of an upcoming applied graph algorithms training course. Is there some way that they can learn more about the course or sort of subscribe for updates when it comes out? Should they subscribe to Twin4j? Is that the best way?
Yeah, I guess yeah. So you can either subscribe to the Neo4j newsletter, or maybe a more specific way is if you're interested, maybe you can put a reply on the community page. Perhaps that's another way that we can keep you notified of when it's going to be launched.
Yeah, you can you can reply to the thread linked below in this YouTube description, and then we will make sure that we continuously update that so people can get an email in there.
Yeah, I guess we can also paste it onto the chat in case you're following that.
And we'll also be sure to announce it through our developer newsletter this week in Neo4j when we launch the course.
Cool.
Great. Well, thanks everyone for joining. Hopefully that was sort of an interesting overview of the data set, how you can import it, some graph algorithms you can apply, and hopefully that gives you an idea of some functionality that you can actually use in a somewhat real world application.
Thank you guys so much.
Thank you, everyone.
Bye. See you next time.
Bye-bye.